Hi, I'm Ted Nelson, introducing Computers for Cynics, Part 0, The Myth of Technology. But first, are you a dummy? If so, get out of here. There are thousands of books for the likes of you. But if you're a clever, sophisticated person who'd like to know where the bodies are buried and how the computer world really works, perhaps some of the insights I'm trying to present will be of interest. The computer world deals with imaginary, arbitrary, made-up stuff that was all made up by somebody. Everything you see was designed and put there by someone, but so often we have to deal with junk and not knowing whom to blame. We blame technology. That's the main thing I want you to understand as you consider the thousands of methods, thousands of products, the fanaticisms, the hopes and dreams, the apparent possibilities, the grim reality. This will draw in part on my books. Computer Lib, 1974, often called a classic. Geeks Bearing Gifts, which Brewster Kahle, the founder of the Internet Archive, calls the best computer history book ever written. I'm sitting in his chair right now. And my memoir, Possiplex, which tells of 50 years of misadventures in the computer family. I call myself a software designer. Now, what you may ask, what software have I designed? Well, there's only one thing that I designed that you're familiar with, and that is called the back button. What's that, you say? It's obvious? Yeah, it's completely obvious. But in 1967, it was obvious to only one person in the world, and I had to fight for it. So that's what this series is about. The ideas and fights behind what laymen call technology. Technology exists, but it's like marital fidelity. There's a lot of it, but a lot less of it than people think. And often what people call technology isn't. I don't understand technology often means something like, I don't understand the crappy menus of this stupid camera. People often say, you can't argue with technology? Of course you can. All kinds of junk is foisted on the public in the name of technology, but you have to know what else is possible. And not be misled by packaging. Part of the myth, thinking that packaging is technology. Here is an iPhone. An iPhone is not technology, it's packaging. Microsoft Windows is packaging and conventions. Microsoft Windows is packaging and conventions. The Macintosh is packaging and conventions. The World Wide Web is packaging and conventions. Underneath these wrappers are the real technologies, TCP/IP and DNS, graphical display and bit-blit, audio digitization and compression, payment mechanisms, encryption, and on and on and on. But the wrapper is what people see, as with pretty girls and dashing men, barely guessing what lies beneath. Now, the greatest myth of technology is the myth of determinism. The belief that technology is determinate, objective, inevitable, that the nature of computers is given. It ain't so. It's all been imagined up. Now, many people think God created the real world, but no one that I know of believes that he, she, or it created the computer world, though many act as if they think so. Key example. Why can't you put marginal notes on a Microsoft Word file or a PDF or a web page? Oops. Why can't you put marginal notes on a Word file or a PDF or web page? The naive answer is because computers don't allow it. The real answer is because Chuck Simone and John Warnock and Tim Berners-Lee didn't think you needed it. Yes, it comes down to individuals. If computers were determinate, you could get the same answer to if computers were determinate and you gave the same assignment to 100 programmers, you would get the same result every time. On the contrary, no way. If you gave the same assignment to 100 different programmers, you'll get at least 75 different methods. It's all very personal. Everyone has passionate ideas and ideals and wants to create software to fulfill those ideas and ideals. Passionate people like Ken Thompson and Dennis Ritchie when they created Unix. Passionate people like Richard Stallman when he copied Unix to make GNU, the free version of Unix. Passionate people like Linus Torvalds when he put the maraschino and cherry in the middle of GNU and created Linux. Unfortunately, Torvalds gets all the credit for Linux, whereas most of it was Richard Stallman's GNU. Anyway, while the great doers have been mostly men, let me also mention Ada Lovelace, the first theorist of software, and in our time, Kate Compton, the creator of a crown to hold your iPhone above your forehead to give you a virtual reality, an augmented reality headset. Brilliantly minimalistic. There are so many ideas to care about. And with ideas come the politics of ideas. There are thousands of computer ideas, and so there are thousands of computer religions, that is, ideas people care very much about. Every faction wants to pull you in. Word, PDF, Mac, web. Every faction wants you to think they are the wave of the future. And because there are no objective criteria, as in religion, there are no objective criteria, there are thousands of sects and splinter groups. Like dog breeds, there are thousands of different computer ideas, and like dog breeds, they can be endlessly combined, making millions of computer ideas. The concepts go on, and many of them have fanatical following. What are the principal computer religions? Oh, Microsoft, Apple, Linux, open source, venture capital, program provability, God knows what else. Specific languages, everyone has a favorite language, and they're fanatical about C++, Perl, Python, Ruby, PCP, C#, Lisp, but which Lisp? East Coast Unix versus West Coast Unix. C shell versus Bourne shell versus Corn shell. I won't even try to explain that. Particular conventions of punctuation have fanatical adherents. Like I refer to the true brace style in C. Object-oriented programming has many fanatical adherents, and then so do specific methods of object-oriented programming, like and then on down to the Booch method of decomposition for object-oriented programming, I kid you not. All of these have their believers. So who gets to decide? Who gets to decide what methods will be used, what ideas will be followed in creating software? That's the politics of the computer world. The politics of the computer world are about who gets to design, that is, decide what the product will be and what's in it, make up the constructs and the mechanisms, decide and polish the presentation and the interface. Everybody thinks they can design great interfaces, and almost no one can. These decisions are determined how? By some objective mechanism? That's politics for you. They're determined by fighting and jockeying and internal politics and maneuvering in projects and in companies, trying to get leverage. And everyone's trying to get leverage and creative control. Now, in Hollywood, they have it down to a system. They determine who directs, but everybody understands that everybody wants to direct, and it's an issue they call creative control. In the computer world, everyone wants to design software, but they don't call it creative control, but it's exactly the same. In software, it's the same issue as in Hollywood, but nobody recognizes it. And that's partly because interactive software is really a kind of movie. What is a movie? A movie is events on the screen that affect the heart and mind of the viewer. What is interactive software? Events on the screen that affect the heart and mind of the user and interact and have consequences. So what's the difference? Interactive software is a movie plus. And that means it needs a director. A director who can fine-tune all of the effects. But for political reasons, this almost never happens. I can think of only one director who fine-tuned all the effective software, and that was Steve Jobs. Because he had the political clout to do it, and the taste and judgment as well. But as long as the industry thinks that software is technology, the process will not improve. Google only hires, quote, software engineers, so do not expect their interfaces to get better. Behind most of the designs, there are fights. And the more you care, the bigger the fight. Consider the history of computer alphabets. First, let's just start in the 50s. First, there was BCD in the 50s. So BCD, binary coded decimal, had 8 bits for 2 characters, and the 2 characters were, 6, I'm screwing it all up. When they got to extended binary coded decimal, you had two numbers, which were 4 bits each, or one 7-bit character. So that way they pack either 2 decimal digits or one 7-bit character into an 8-bit byte. Now, that's pretty stupid, isn't it? So along come many proposals, but along comes especially Bob Beamer with the ASCII committee, and creates the ASCII code, which is much more sensible. Every numeral gets its own 8 bits, and every character gets its own 8 bits, and they have 256 of them, and it gets accepted after a great deal of political fighting. Okay, and that was passion of Bob Beamer. He fought and fought to give us ASCII, for which we were all grateful. But then what happens? Well, in Europe they said, "Hey, our characters don't fit on there. We have all these doodads on our alphabets that don't fit in your 256 characters. What are we going to do?" So ASCII was kicked over to Europe and called ANSI, and became the European standard with all the doodads on the characters and characters. And so that was another political trip. And then in Asia they said, "Hey, what about us? We've got thousands of characters. Hey, how many characters are there in the Japanese alphabet?" No one knows, but certainly tens of thousands. So the techie committees get together and they assign, first of all they say, "All right, we're going to go to 64 bits for every character. That'll take care of everybody." So they allocated a certain number of characters to each language in the world. And then the bloodletting began, because there weren't enough characters for the cultural history, for all the writings of Japan, Korea, Thailand, Vietnam. They all lost characters, smashing the history and literature of these different cultures. And of course, the techies said, "Well, that's progress." So was the Unicode mess technology? No, it's culture politics masquerading as technology. So technology is a mask worn by all kinds of political parties in all kinds of fights and situations. So-called technology is also about capture, getting permanent customers chained into their seats. Everybody wants to capture you, either for money or to get you into their computer religion. So the Babel of conflicting methods, techniques, enthusiasms, and conventions is also designed to entrap, entangle, and entice for either religious or commercial reasons. Capture worlds, I think that's the term I prefer right now, but we could also call them platforms or monopolies or prisons or Venus flytraps, or there's that nice term from espionage, honey traps. Anyway, your software choices are like any addiction or religion. They want your loyalty and they want your money, and they want you to think like them. Or even if they're idealists who don't charge, like Richard Stallman and the Stallman cult, they want believers who will swell the ranks. The computer world is composed of techies, schemers, and sheep. Also a few hymnists, of which I try to count myself. The techies see more possibilities. The schemers try to build and combine, often not knowing the possibilities, and the sheep just choose from what they see. The ones who get the farthest, of course, are the techie schemers, like Larry Page and Sergey Brin and John Warnock. But the media don't quite get these distinctions. For example, my favorite example is the movie The Social Network, which presented Mark Zuckerberg, the founder of Facebook, as an ironic but semi-autistic nerd. In fact, Mark Zuckerberg is a fencing champion who speaks fluent Latin and Greek. So much for your stereotypes. Nobody knows where the world is going. The future is just starting, as always, and now is the knife edge between past and future. Which way the knife will twist into the oncoming universe of possibility. The media are now encouraging a new faddist world of iPhones and Twitter and YouTube with all this great stuff that's free for everybody. But ancient Rome, they say, went downhill when the illiterate masses expected everything to be free. Bread and circuses, pod et circenses. Will today's freebies take away our freedoms, or will it all be more and more sweetness of life? Thank you. Hi, it's Ted Nelson with another episode of Computers for Cynics, looking at what's wrong with the computer world and how we got here. Today's lecture, The Nightmare of Files and Hierarchical Directories. Everybody learns at the beginning the fundamental structure of the computer universe, and the most basic thing they tell you about computers is files and hierarchical directories, now called folders, but they're not any different. These are the latitude and longitude of the computer world. And this is just one of the lies of computer basics. You see, computer basics pretends to describe the world as it has to be, but it merely describes the world as it is, and the world could be many different ways. We've just chosen conventions and traditions. Computer basics are conventions and traditions posing as reality, plausible fictions that have, in many cases, hung on too long. I've had techies say to me, but everything is hierarchical. That's not science. That's metaphysics. I could as well say that everything is cross-connected, overlapping, and interpenetrating. Would that be metaphysics? Not if I say people's lives are cross-connected, interpenetrating, and overlapping. People's projects and concerns are cross-connected, interpenetrating, and overlapping. So if that's the way people's lives and concerns and projects are, that is how we should be able to represent and manipulate them, isn't it? Okay. How we got here. The story of files. Well, how files began. Originally, in fact, at the turn of the century, in 1900, a digital file, was a box of punch cards. Punch cards appeared for the census of, I think, 1888. But this box of punch cards with a name handwritten on the front became a lump file in the computer with a name. Now, we don't examine this very often because it is assumed that the world is made merely of data lumps. Well, what about metadata? Metadata is what isn't in the lump. Now, it's all data. Why isn't it in the lump? Because it has not been convenient to put it there, because we don't have a mechanism for putting it there. But it's all part of the same structure. The file that has, the file lump has to have this other data to be used, to be understood. But that other data is given second-class status and put off somewhere else and called metadata. There's something, the lumps are no longer pure. And the boundary to metadata becomes foggier and foggier. These things should be represented a lot better. All right? Random facts about files. Paul Allen's the backslash in Windows directories was put there by Paul Allen for no particular reason. So that had to be coped with. The dot suffixes, .exe, .jpg, and so on, appeared first in Windows, but then, because they were useful, went on to Macintosh and others, made the file names less readable, but there you are. What about the fact that you can't read Macintosh file names on a PC and vice versa, and that Unix and Linux doesn't allow spaces in file names? Well, that makes a problem for files coming from Windows and Macintosh, doesn't it? Well, they think that maybe Unicode will solve this. Don't bet on it. Okay, let's jump over to the story of directories. I go fast here, so not all the transitions are perfect. The story of directories and their hierarchy. I haven't been able to trace the exact history, but obviously directories began something like this. They had a bunch of files on a tape, and they said, well, how will we keep track of what files are on this tape? Shall we write it down on a piece of paper? Well, let's make a file that's a list of the names of the files on the tape, or the disk, wherever this began. Well, that works. And since one of those file names can be the name of another list of files, that gave us hierarchical directories. So the method sprang up and became a tradition, plausible and extensible, and assignable to the categories that people had. Because, for example, if you were a programmer at Bell Laboratories in the 1970s, hierarchical directories made perfect sense because the number of projects you could have, what would be in your career at Bell, 20, 40 big projects, and they would be divided neatly. And so putting them in directories with hierarchies made sense at the time. Now, how does that work inside? We can begin history anywhere, but let's say that the directory system became crystallized with a system called Multics in the mid-60s. Multics was a huge thing that didn't get a lot of traction, but its little child, its conceptual child, was Unix at Bell Laboratories, a small version of Multics, and the first practical, reliable time-sharing system that was essentially free to universities. It would have been the standard for personal computers, but the Bell lawyers tried to charge $25,000 for it, and so that's not what happened. Okay, how did they crystallize the directory structure inside Multics and Unix? They said file name can be any length. It was a lie. They said directories could be stacked to any depth. It was a lie. But conceptually it was true that you could have any number of characters in a file name. It's just that you'd run out of space and not know it. And if you had directories too long, you'd run out of space and not know it. Okay, but in any case, they had a robust mechanism, provided you didn't overstep these unseen boundaries. And this robust mechanism was called the file system, which essentially began at Unix and has been standardized to this day so that all computers have the same fundamental rules for file systems, but each file system, there are many file system types. For example, I have here a disk drive, a hard drive, formatted for Windows. It uses the NTFS file system, which is the best of the Windows file systems. And we have here a hard drive formatted for Macintosh, using the HFS Plus file system, which is the best of the Macintosh file systems. Now, you would think that, as a courtesy, Macintosh, Apple, would provide a way that you could read the NTFS file system on the Mac, and Windows, by courtesy, would provide a way that you could read the HFS Plus file system on the Windows. Not on your life, buddy. Out of spitefulness and the nasty competitiveness of trying to imprison their users, they do not make these file systems available, and so you have to buy them from third parties, which of course is a step that most people don't go through, and so they are crammed into the one system. Now, how does the file system work? A file system, as established by Unix, has a couple of tables on the drive and a matching program inside the computer. So when you say you have the NTFS file system, that means you have the program in the computer so that you can read the file tables which are inside this drive. And there are two tables. One is the so-called inode table, which is the list of positions occupied by files, the starting positions and lengths on the tracks and sectors of this drive. And the second table, I don't remember the actual name of it, which is the trellis of path names and paths that is applied over those inodes. So that by manipulating those two tables, the computer can neatly separate the two functions of moving files around, copying files and deleting files, which it does through the overlay table of paths, and actually saving the files and reading them, which it does through the inode table, reached by the overlay table of paths. I mention all this because it shows you how the kind of thinking that had to go into it, and at least at that level it's gotten efficient, but it's gotten efficient only around the conventionalized system of hierarchical directories with files at the bottom. Incidentally, the myth in Unix was that everything is a file. The wastebasket, as we call it now, is a file. It was called the dev null, and it occupied a place in the directory tree. It wasn't a file. It was an inode. In any case, there are several secret problems. One is that you can actually run out of inodes and the disk will be, quote, full, because you've got to put a lot of little files on it that don't remotely take up all the space, but the inode table is exhausted. That's almost one of the more benevolent issues. The worst issue is running out of space in the directory names or in the directory depth. So when a file is inside a directory, inside a directory, inside a directory, inside a directory, all of those names are concatenated in the directory table, and it can become too long, and then your file is lost. Now, there may be ways you can get it back out, for example, by taking out the inner directory with your mouse and taking out the inner directory of that. But jeepers, these are serious issues. So those are technical issues that are wrong with the world of files and hierarchical directories. Oh, yeah. Hey, what about your digital camera? That's got a little directory called DCIM, or digital camera images. And so that, too, inflicts on you mysterious names and mysterious places. All of this, I submit, is fundamentally broken. It is a nightmare for most users. Not just the incompatibility of file names among operating systems, but there's no way to annotate files. How do you point out, for example, that a certain file is questionable? You can't put a question mark in the file name, at least not on Windows or on Unix, because it's a disallowed character. Why? Because it was used in the Unix command structure and couldn't be, therefore, in the Unix file system. Well, there are a lot of times you want to use question marks in file names because there are so many unknowns about what you have to deal with. That's just one. But there's no way to annotate, and it's dangerous to change the names of files, change their directories, because, of course, they may be referred to from elsewhere. You may have shortcuts to them. Now, what's a shortcut? It's a one-way pointer that can't be moved, that doesn't know it's connected, doesn't know if the thing it's pointing to moves. This is inherited from Unix. They call them hard links and soft links. They had two types, and neither of them allowed for the moving of files. It's impossible for most people to keep track of where they put things or what their names were. I tell you this is a fact about human psychology, which merges badly with these facts about the directory systems and structures of the world. Backups become merely gnarly black holes of strange arrangements of the past, and we're stuck with data archaeology trying to understand what you've got there. I'm running out of time. Trying to organize your life and work, and that of your work team falls apart. How could it be different? Suppose we were starting over. The issue is controlling our work and understanding. Starting over from scratch is awfully difficult. And I wanted to read you a quote. See if I can get it in. There's nothing more difficult to take in hand, more perilous to conduct, or more uncertain in its success than to take the lead in the introduction of a new order of things. Niccolo Machiavelli. Thank you. Hi, I'm Ted Nelson with another serving of Computers for Cynics. Today's proposition: it all went wrong at Xerox PARC. For the first 6 minutes, I'll tell you the standard story, and then we'll get down to business. First, let's start with the legend. The people at Xerox Palo Alto Research Center, called Xerox PARC, are treated as gods. in the standard computer history, they created the modern computer world as we know it. They took the bad old geeky computer with its keyboard commands and the bad old text editing programs with their keyboard commands and built instead a magic toy shop. They gave us mouse pointing, multiple windows on the screen, pull-down menus, applications running in separate windows, word processing with fancy fonts, sometimes called desktop publishing. Virtually every computer in the world now has this structure, usually called the modern GUI, or graphical user interface. But many other graphical interfaces are possible, so let's give proper credit and call it what it is, the PARC user interface, or PUI. Prehistory, Xerox and how it grew. Once there was a company called Haloid that made photographic supplies, chemical and photographic paper, but in the 1930s they bought a patent on a process that would make pictures by static electricity, with no chemicals or special paper. After 2 decades of development, they brought out their magical picture machine, the 914 copier, and they changed their company name to Xerox. The 914 copier revolutionized the world. Nobody expected all the copies that people would make. So throughout the 60s, Xerox was wallowing in money as if there was no tomorrow, meaning that they were free to spend a lot on R&D rather than paid in taxes. History of Xerox PARC. Some smart guys at Xerox managed to set up a futurist research center. Xerox PARC was built in California, partly so upper management would bother them as little as possible. A key department head was Bob Taylor, who had been the computer funding guy at the Defense Department. He went cherry-picking among computer guys he knew, hiring them away from universities and companies. They were idealists and enthusiasts and hard workers. Taylor was determined to build some kind of future, some new kind of future, but he wasn't sure exactly what it was. I'll know it when I see it, he said, and cherry-picked the ideas his people came up with. And now for the first PUI. The guys at PARC had been forbidden to buy computers, so they began by building their own. They built a lot of little computers called Altos, little by the standards of those days, but putting far more power in front of the user than anyone had seen before. The Alto was hot and fast and could have fancy fonts on the screen. By and by, the Alto software package included icons, desktop, wastebasket, mouse, apps with undo, and strange operations called cut and paste. Word processing with fonts instead of the clunky letters traditional for computers. You saw Times Roman and Courier and fancy script fonts. It printed out the same way. This was called WYSIWYG. What you see is what you get, meaning what you see on the screen is what you get when you print it out. A slogan actually from a transvestite comedian named Flip Wilson. And this was the first PUI. And Bob Taylor saw it and pronounced it good. Outside the walls of PARC in the 1970s with our noses pressed to the plane, we computer guys heard a lot about the Alto package and seethed in jealousy and hope. We heard of it mostly from PARC's great publicist, Alan Kay, a great programmer but also a great talker. At conferences everywhere he talked about what PARC was doing. I must have seen his spiel 5 times. After Alan might begin by showing a video of some child using an Alto, pointing out drawing with a mouse, he told us the child would soon be a programmer. He told us that his small talk language would let any child program, including graphics, music, and who knows what else. We believed it. Thousands saw Alan's demos at conferences, and the lucky ones got invited to go to take tours at PARC. I got mine in 1975. We all wondered, when would this stuff come out? It took a long time. The PUI gets out of PARC. Climax 1. Xerox screwed up trying to market the PUI. They refused to sell the Alto, and the PUI machine they tried to sell, the Xerox Star, was much too expensive. And they knew they were running out of time because their patents would soon expire, and the copiers and printers would flood in from Japan. Having spent untold millions developing this new package, the PUI world, they wanted some payback, and they didn't know how to market it. So they went to a guy who might. Steve Jobs got to walk through PARC in 1979, and see the Alto. He actually made Xerox pay for the privilege of showing it to him. And Jobs became fired up and said, I can sell this. First, Jobs led a team to develop Apple's first PUI machine. It was called the Lisa, and it cost $10,000. It was a flop. So then Jobs led the Macintosh project, Apple's second PUI machine, and he insisted on the lowest possible cost. The Macintosh marketing rollout in 1984 began with a spectacular commercial on the Super Bowl directed by Ridley Scott, which presented the Macintosh as a great liberation of mankind, and this time the PUI caught on big. Soon Bill Gates started his own PUI called Microsoft Windows, and the PUI fight was on between Apple and Microsoft, continuing to the present day. Climax 2, how text systems got out of PARC. There were 2 important text development software projects at PARC. The first of the great PARC text projects was the editing program with all the fonts, which everyone loved. It was called Bravo by Charles Simoni. By and by, Simone left PARC and took his Bravo project with fonts to Microsoft, and it became, ta-da, Microsoft Word. Simone guided the growth of Microsoft Word for a decade, building it up to Microsoft Office. Meanwhile, the program for making all the different printers work with all the fonts was called Interpress by John Warnock, and by, Warnock too left PARC, and Interpress became, ta-da, the PostScript language, which Warnock managed to get into laser printers everywhere. PostScript evolved into the PDF format, which is widely used for frozen text content with fonts. Now, let's talk about the downside of the PUI. This is no longer the standard story. I have to be careful what I say. I want to stay friendly with people like Alan Kay and Larry Tesler, but somebody has to say these things. PARC has had so much fawning adulation over the years, it's time to balance the story. Downside, the social aspect. There was a lot of friction between PARC and the rest of the computer world. Taylor hired away a lot of top people, for example, the main guys of Doug Engelbart's lab, breaking up his team. We were at dinner with Doug a few years ago when Doug actually wept at his people's desertion and what he felt was Taylor's betrayal. Doug's former sponsor, Bob Taylor, turning around and spurning his vision of deep cooperative work so important for the world. Here was another irritant. Alan Kay would generally begin his spiel by saying that PARC had the top 5% of computer people. You can imagine how the rest of us liked hearing that, being told we were inferior peasants. The press continually speaks of PARC as a wonderful, carefree playpen for free-living, liberated technical guys. Well, when I got the PARC tour, I found the atmosphere very unpleasant, indeed very abrasive and aggressive. Was it just me? I don't think so. Downside, a fig leaf. The icons and windows were just a fig leaf on the conventional operating system. Directories were not called folders, but this did not change them or their structure or hierarchy in the slightest. Using icons, you could still do some of the standard functions. They'd found an exact graphical way to command the operations, create new file and directory, move file and directory, delete file and directory, and these operations were a little safer than in Unix, where one character incorrect would destroy everything. But otherwise, they changed the operating system in no way whatever. Consider the wonderful undo command. That was only in applications. There is no undo in the PUI operating system. They didn't change the operating system in any way. They just hid it. Downside. The interface program was finished. You couldn't program the views. Example, your program couldn't draw a line between the contents of one window and the contents of another. See transpointing windows on the web. Example, there was no zoom. The screen was locked to paper thinking a fixed size, though ideas have no fixed size. Downside, what they took away. Xerox PARC changed the operating system in no way whatever except for what they took away. They took away the right to program. Unix shell scripts, invented by Frenchman Louis Pouzin, encouraged casual programming and easily led up to the C language, which was serious programming. All that was taken away, and no, small talk did not come out for the kiddies or in any form that let you change the PUI. Downside, application programs. PARC created the application, but an application is an enclosed file. You can't mix or match what applications do any more than you can mix or match the traits of your previous boyfriends or girlfriends. You can't change the interfaces of applications just as you can't change the interface of the operating system. You can't script the movement of content or pieces. Applications were cattle pens. You go from application to application like a cow in a chute. So does your data. You are a prisoner of each one in turn. Downside, they dumbed down electronic documents, replacing structure with fonts. In Doug Engelbart's text system, the first text system, text could be overlaid with connections. They threw that out, and they stuck to the standard computer tradition of one file equals one document. Do-de-do. In other words, they simulated paper, the paper dime, but it was dumbed down paper. You couldn't write on it. They simulated paper under glass. You couldn't rearrange it freely on the page. You could only rearrange it with side-to-side tab settings. You couldn't protect part of a document. Why not? You just want to work an area. Can't you protect the rest of it? No, they extended the conventional file model from Unix, where you could protect a whole document, but not part of it. Again, this was just a fig leaf covering the conventional operating system and file structure. And it had this locked size, 72 dpi matched to your WYSIWYG printer. Where did that come from? Why? 18th century typesetting. In summary, the PUI dumbed down the computer to a paper simulator. What PARC did was make a machine for secretaries, and not even for high-level secretaries, for typists. So they wouldn't have to type a document repeatedly from scratch, just put in the changes. And the other low-level secretary functions were file a paper document, move a document or folder, throw away a document or folder. All those they did by icons. Duh! What more could you possibly want? Downside. Now we get to cut and paste. I learned in high school that the craft of writing consists mainly of rewriting, and rewriting consists mainly of rearrangement. After you've written something, it's usually in the wrong order. You study it, then you cut it apart into separate pieces of paper, then you arrange the pieces of paper in the right order, adding or replacing text as you need to. This can take some time. You may have the pieces of text lying around on your desk or your bed or the floor. Then when you're all done, you attach the pieces in the right order with staples or clear tape or often with paste. And for hundreds of years, this process was called cut and paste. It was used by the great author Tolstoy. The novelist Balzac had a sharp knife on a lanyard around his neck to cut up his manuscript for rearrangement. I've also been told that the great chemist Mendeleev moved slips of paper around representing the chemical elements until he found the periodic table. And in my first salaried job, at my hometown newspaper, my first task in the morning was to fill the paste pots for the reporters, who would come in and type their stories, then cut them up and rearrange them. Did PARC give us a good way to move the pieces of a document around on the screen to find the right order? No! They gave us an abominable editing mechanism, propagandistically hidden behind the former terminology. The abominable mechanism is the hidey hole where you put something you want to move, and it's called the clipboard. And hiding something on the clipboard has since 1984, when the Macintosh came out, been called cut. Then you choose where this one piece goes and blurp it out, and this blurp out action has been, since 1984, been called paste. Not only did PARC take away the fundamental method of reorganization and give us a hidey hole instead, but they gave that hidey hole the name of the previous method, which in true Orwellian style has made people forget. Note that the Macintosh laid it on us in 1984, the Orwellian year. Now, this twisting of the previous terminology for an entirely different function was perpetrated by Larry Tesler, who was one of the nicest guys I know. As the Christians say, hate the sin but love the sinner. I've been corresponding with Larry, no time to read his beautiful reply. He thinks old-fashioned cut and paste is a complex method for professionals and researchers, and that ordinary people don't need anything better. I'll be putting his beautifully written reply in the next edition of Geeks. Now, the PARC people said they tested the PUI. Whom did they test it on? I believe secretaries and Xerox upper management who didn't know any better. Did they test it on people with vast amounts of content to organize? I don't think so. Did they test it on historians, great writers, great novelists, or maybe you who are trying to manage multiple threads of narrative and connection? I don't think so. Did they test it on super secretaries like paralegals who have to keep track of profuse connections, super secretaries like administrative assistants who live on an item storm of incoming demands? I don't think so. And those people are still screwed, as are you and I. Winding up, the Xerox PARC dumbed-down was about mimicking the past. They called their constructs metaphors, believing that everything had to resemble the past and not imagining they could create new, unfettered constructs. They dumbed down the computer, making it a paper simulator, and in a Faustian bargain, gave us the sensual pleasures of fonts in return for giving up any forms of connection or organization. They threw away Engelbart's work on structure and collaboration, which did not fit on paper. In order to sell printers, they threw away the universe. Thank you. Hi, I'm Ted Nelson with another quickie of Computers for Cynics. If you still think computers are objective and scientific, let's clear that up right now with today's plateful, the database mess. What is a database? A database is any systematic attempt to keep track of things. Lists, tallies on walls, card files are databases. In computerdom, there are dozens of database methods, thousands of products, all plausible, but the different methods combine very badly. And as in most areas of computerdom, the whole thing is indeterminate, absolutely arbitrary. It's just a matter of what has caught on and what hasn't. Here's the problem. It is natural to think we can keep track of things on computers. Always the dream of both management and hobbyists. Just a small problem of specifics, or as the Shakers used to say in the 19th century, God is in the details. Well, computer databases are basically a good idea, but frequently with terrible consequences and unholy mess. The term database is misleadingly technical sounding. Anything can be a database, and individuals will use anything. Everybody uses text files for keeping track of something. Everybody arranges things carefully in a lot of people arrange things carefully in directories. We even put information in unsent Gmails. I've heard of using PowerPoint for storing audio files. Who knows? Whatever. Corporations too have many options. There's a variety of choices. Key value database, trees of various kinds, relational database, object database, big table, but you can't have that. That's Google's proprietary database system where they divide problems so they can be simultaneously solved by hundreds of thousands of servers. What about Hadoop or Hadoop, which reverse engineers Google's big table system? Well, and what about Triple Store, the latest comer to the field? And how about Magnetronic Reservisor? I'm just kidding, we'll get back to that one. So for individuals and corporations, we have the same problem, whatever the methods. Dividing what you're dealing with into structures or schemas, setting up the system, maintaining the system, input and checking, backing it up, and then worst of all, the problem of changing anything in the arrangement. But for companies, it's worse in some ways because with big systems come big problems. Suppose you're a railroad. What do you have to keep track of? Well, you have to keep track of track, railroad cars, where they are now and where they're intended to be and what they'll have in them when. Employees, their experience and salaries and locations and addresses, schedules of trains, of personnel, supply delivery, maintenance conditions and schedules, all in a unified conglomerate. It's the unified conglomerate that's the problem. And as the company changes, you want to change the whole setup so that it includes airplanes or restaurants or plantations, whatever else the railroad goes into. So the problem of databases is conceptually simple, but huge to do. There's no right or wrong way to handle databases, just particular people who say, well, it's got to be done this way, because usually it's relational database, and that's how they're used to making a living. There's a cognitive dissonance issue here. Okay, history. In the 60s and 70s, the computer was the database. You had languages like RPG and COBOL, which would essentially stick things in slots or fields and read them out. And then in the mid-60s, IBM switched to IMS, which became the database system for some years. But they had a very big system at IBM that they didn't market to the public. It was called SAGE. It was for keeping track of incoming Soviet bombers. And it did a very good job as far as we know, and its successors are still operating today. Well, this was adapted. It was beaten into plowshares in a very interesting way, and its successors are still running. Talk about accidents and technological indeterminacy. An IBM salesman named Smith was on an airplane with a president of American Airlines named Smith, and because they had the same last name, they got to talking. And President Smith said, we want to build this reservation system, and it's going to be called Magnetronic Reservisor. And the IBM salesman said, wait a minute. And when he landed, he got on the phone to Tom Watson, and he said, could we make it passenger planes instead of bombers? I'm embroidering a little, but that's essentially what happened. And so the SAGE system became the, at least according to Wikipedia, became the Sabre system, which runs most of the world's airlines today. So when dinky computers came in the mid-70s, the personal type computers used either for personal or for company, it all started over again, inventing ways to keep track of things. So PC write for people who used plain text files for holding data. PC file by Jim Button for holding preliminary sorts of databases of fields, and VisiCalc came in, and that made the Apple II take off because nobody had ever seen anything like it, and while it was spreadsheet, not technically database, a lot of people used it that way and still do. All these helped people keep track of things, maybe sometimes, because of course a lot of people, seeing how complicated it was, gave up. Anyway, what about the most popular system of all, relational database? Well, it was tables with fields people were doing back in the old days, and so name, address, phone in some kind of a table. And one guy named Codd worked it all out with endless theoretical mathematical musings, trying to derive it from first-order propositional calculus, that sort of thing. And he insisted on 13 axioms, which he called his 12 rules, and which are now universally ignored. But he wrote a paper in 1970, which made a big impression and started people creating systems, all with the same general approach of tables pointing at tables. Now, the following was told to me by a guy from IBM who said he succeeded Codd, that IBM told Codd he had to deliver a product in 2 years, and he said, "That's beneath me," and quit. And so the 500 PhDs who had been working under him were at a loss. But to give them something to do, this guy gave them the SQL system, the SQL language, which is now the universal language for setting up databases and querying databases. So who created relational database? Nobody, because the father repudiated the child. So, nevertheless, relational database is now standard, perhaps for none of the reasons we heard it, but rather because it provides a first line of defense against embezzlement. You see, in the 1960s, programmers had started to embezzle by essentially taking small differences when they divide a sum, and when there's a fractional cent left over, they just tuck it off in some special place. Well, the relational database, and especially SQL, prevented this because two programmers could look at each other's SQL and say, "Wait a minute, what are you doing here?" And that put a stop to that kind of thing, mostly. But relational is not the only way. So let's talk about the dirty secrets of the database world. One is simply the great variety of database systems and their incompatibility, and the incompatibility of one relational database with another. We'll get back to that. There is no determinate way to set up databases. You can have competitive layouts even if the structures are the same. For example, there are companies which give databases away to users so that the users will order their products. But two competing companies in the same field will give away databases which are arranged in completely different order and structure. Why is that? Because it's too much trouble to learn more than one arrangement of the database. I'm told this is the case in the avionics industry, and it's the case in the electronic parts industry, that there are two major catalogers, and they each give out databases to their customers which are completely, impossibly different from their competitors. You still think it's objective and scientific? Okay, let's talk about database fiascos. Notably, the poster child of database fiascos, the National Health Service database fiasco in England, United Kingdom, excuse me. The United Kingdom has a National Health Service, which essentially gives medical service to everybody who can afford better, and everybody who enters the country and gets a tummy ache. And they were going to set up a database system to keep track of all of these patients. And they let out huge, expensive contracts, and to date have lost billions of pounds, that's even more billions of dollars, on a system which doesn't work. And supposedly they're still working on it, hoping that maybe someday it might. Okay, perhaps the dirtiest secret in the business information world is how hard it is to combine databases, especially when two companies merge. The differences between databases have enormous consequences. So to reconcile the tables with their different schemas and different ways of referring to things, may take the guys in the back room decades to catch up. So this is where a German firm called SAP comes in. If your company gets their databases from SAP, you will do it their way, and it will work, because every department has to operate in exactly the way that SAP has set it up. Okay, well, it's very successful, and if you don't mind setting up all your departments the way SAP does it, you're in good shape. Another dirty secret, general problems of agreeing on conceptual structure. This is where, if you're in an intellectual company where they start by thinking the subject out, then you have committee fights over the schema and ontologies, which go on and on. All right, for databases, next problem, for databases to be universal and shared, everyone has to agree, not just on the structure, but on the ontology, that is, on what the concepts are going to be forever and ever. So we have to agree on the categories and terminology for all time. Are you laughing yet? This concept is called, among other things, the semantic web. Of course, instead of agreeing for all time, we can just delegate our language issues to hundreds of committees, which will do a wonderful job to coordinate our thinking, right? Summing up, today's commercial database is divided between IBM, which runs the big iron through which flow the great monies of the world, and Oracle, or Larry Ellison, which pretty much has the rest. And if you're a regular person that wants to save something on a database, well, lots of luck. You've got, of course, you want to visualize, to mentalize, to keep track of and sort your life and all your accounts and priorities, your plans, your schedules, events that you want to keep track of, past and future, places. Well, you've got Quicken for accounts, you've got address lists for people and calendars for schedule. What more could you want? As to events and places, well, lots of luck. And now in closing, to heads of corporations. Be nice to your database guys. They work very hard for very little thanks. They need your appreciation, even though you know perfectly well you can't possibly fire them. Thank you. Turn this thing off here. Was it running? Hi, I'm Ted Nelson with another dollop of Computers for Cynics. Today's helping Pooey Wars, the dance of Apple and Microsoft. Two stories which are really one, but you can't understand them alone. Microsoft is created by two college dropouts named Bill and Paul, an ideal partnership between aggressive and quiet. They'd already had a successful software company in high school. Apple is founded by two college dropouts named Steve. Fortunately, one is called Woz. An ideal partnership between aggressive and quiet, and they'd already done business stuff together. The clock of the personal computer world starts ticking in December 1974 with a fake picture of the Altair computer on the cover of Popular Electronics. A few of us were trying to get ready before that, but that's when it hit the public. 1975, year one of personal computing. Thousands of people are buying this Altair computer kit. Crazed, hopeful lemmings who don't know that there's no software or even what software means. Do Bill and Paul wait to get the degrees? No. They drop out of Harvard, and Bill phones Ed Roberts, the head of MITS, who makes Altairs, and says they have a version of BASIC that will run on the Altair, which would be the first personal software available anywhere if they actually had it. Ed Roberts says, show me. Bill and Paul drop everything to develop BASIC on the Harvard PDP-10, and they do it in 3 months. This is the first legal bullet they dodge. Harvard never goes after them for this development using university resources. Paul demonstrates their BASIC to Ed Roberts in March. Roberts grabs it. Their BASIC will be called Altair BASIC. And on April 4th, 1975, they found Microsoft with no backers to interfere. 1976, year two of personal computing. People still have to buy kits and build them themselves, and nobody yet is selling a full computer individuals can buy, meaning under $10,000. MITS is acquired by a company called Pertec, who think they're buying Altair BASIC. Microsoft dodges another legal bullet. Bill gets it to keep BASIC. It becomes Microsoft BASIC. Meanwhile, on the West Coast, Steve Woz, the engineer, builds a computer all assembled on a single board. They call it the Apple computer. Now we call it the Apple I. Jobs, the salesman of the two, thinks the Apple I will be a success if they sell 50. He sells 50 on the first sales call. Apple is founded as a partnership between Woz and Jobs and another guy who chickens out, but no backers to interfere. 1977, year three of personal computing. 3 fully assembled computers hit the personal market with keyboard and screens, not just a kit or a board. The nicest is the Apple II, with insides by Wozniak, software and hardware. Box and packaging by Jobs. It comes with 2 levels of graphics and Microsoft Basic. It's a huge success, and Apple becomes a regular company. 1979, year 5 of personal computing. Xerox wants to sell its fancy new interface, but they can't, so they go to someone who might, Steve Jobs. So then comes Jobs' famous 1979 walkthrough through PARC. They show him the PARC user interface, or PUI, often called the modern GUI, and it knocks him out. He famously says, "I can sell this," and Xerox invests in Apple. 1980, year 6 of personal computing. Still, Microsoft is selling no operating system, but in July, Gates gets a super deal. IBM asks him to build an operating system for their forthcoming IBM PC on the 8086 chip. Opportunity knocks. Now, it just so happens that Gates knows a guy named Tim Patterson, who has already created the operating system that IBM wants, which Patterson calls his quick and dirty operating system, or QDOS. This is opportunity knocking twice. Bill sends Kay Nishi down the street to buy QDOS from Tim Patterson for $50,000, a better deal than Manhattan for $24,000. If IBM had known about QDOS, they bought it themselves, and this would now be a very different world, in one in which IBM might still be a big player. 1981, year 7 of personal computing. The IBM PC comes out with Tim Patterson's QDOS rebranded as PC-DOS, and Microsoft is now in the operating system business. Microsoft has dodged another legal bullet because Gates hasn't given IBM an exclusive and keeps the right to sell QDOS for other machines. But since there are no other machines that will run it, IBM isn't worried. They should be. With their clout at that time, they could have forced Gates to give them an exclusive, but they didn't. Meanwhile, at Apple, Jobs is working on his first PUI, the Lisa computer, but he's unseated by Apple's now Byzantine internal politics. So Jobs grabs control of the Macintosh project, and that's his second PUI. 1983, year 9 of personal computing. Apple comes out with its first PUI, the Lisa. The project Jobs was thrown off. At $10,000, it's a critical success but a flop. 1984, year 10 of personal computing. Jobs' second PUI comes out, the Macintosh, $2,500 with 128K of memory. It is a big, big hit, and the PUI wows the world. Meanwhile, in the Microsoft world, the Phoenix BIOS comes out, a piece of firmware, software on a chip, which allows anybody to build an IBM clone, because supposedly it doesn't violate IBM's copyright and on the inner kernel of the operating system, the BIOS. IBM could have fought it legally. IBM should have spent $1 billion, but they let it go, and soon they were practically dead. This wasn't dodging a bullet. It was a gift to Microsoft from the legal universe. What was Phoenix's gain was IBM's super loss and Microsoft's super gain. Microsoft could now sell the operating system to everyone, clone makers abroad and everywhere. Doom for IBM, supremacy for Microsoft. 1995, year 11 of personal computing. By now, Bill wants a PUI for himself, and Microsoft is way behind the PUI curve. Gates brings out Microsoft Windows 1, attempting the impossible, bringing a PUI up from Tim Patterson's quick and dirty operating system, or now called MS-DOS. At Apple, due to crazy internal politics, the guy Jobs recruited as president of Apple insults and isolates Jobs, cutting him off from the company he founded, even though his Macintosh is now a spectacular success. Jobs leaves Apple, sells all but one share so he can go to the stockholder meetings, starts Next Incorporated, another computer company. He's rich. He doesn't have to do all this. But on he goes. 1986, year 12 of personal computing. Jobs buys Pixar. Wish we could discuss that. 1987, year 13 of personal computing. Microsoft Windows 2, still a clumsy PUI, but pushing onward. 1988, year 14 of personal computing. Apple sues Microsoft for imitating the PUI. Why? Apple didn't invent it. PARC invented it, but evidently Scully, the guy who fired Jobs and is now running the company, kind of, evidently Scully thinks it's their property, and so they waste a lot of money on the big lawsuit. Meanwhile, at Next Incorporated, Steve Jobs brings out his third PUI, the Next Machine, a critical success, but too expensive at $6,500 and a business flop. Jump to 1993, year 19 of personal computing. Under Scully, Apple has been sinking. Scully leaves Apple, but the board doesn't want Jobs back. 1995, year 21 of personal computing. Apple gets closer and closer to bankruptcy. As Apple sinks, Microsoft rises. Windows 95 comes out. Still built up from QDOS, Microsoft's first real triumph in the PUI wars, it allows long file names. 1997, year 23 of personal computing, the board of Apple capitulates. It's either bring back Steve or liquidate the company. Jobs is asked back as interim CEO. This is like the old Western movie where the cowboy is hanging by one foot from the galloping horse and manages to pull himself back into the saddle. Steve's first trick is to borrow $150 million from Microsoft, since Apple is broke. Why does Jobs borrow the money? He has it. He could put it himself. Hey, why should he? Why does Bill lend him the money? Bill needs a competitor because the U.S. government is breathing down his neck with antitrust. 1998, year 24 of personal computing, the government bears down on Microsoft with an antitrust prosecution. Year 2000, year 26 of personal computing. In the antitrust case, Judge Jackson orders the breakup of Microsoft. Didn't happen. Year 2001, year 27 of personal computing, Windows XP takes Microsoft to the pinnacle of the PUI wars. Meanwhile, in the antitrust case, Microsoft consent decree ends the antitrust with a few slaps on the wrist. Microsoft has to reveal their interfaces for a certain length of time and give copies of their software to schools. Hey, don't throw me into the briar patch. 2002, year 28 of personal computing, Apple's Macintosh gets a new operating system, OS X. Steve Jobs' fourth PUI. Jobs has done the impossible. The old Mac operating system, which he created but which had gone from bad to worse, was fundamentally broken, so he dared to start over, inflicting it on users incrementally, trying to hold his fanatical customer base while pulling the rug out from under them, bringing over the system he developed at Next, built on rock-solid Berkeley-free Unix. Let's take the cowboy analogy one step further. It's as if the cowboy, having climbed back into the saddle, pulls another horse into the saddle behind him. And the Mac, which was less reliable than Windows, is now more reliable. Plus, it contains Unix, giving back the right to program that the original PUI took away. Year 2006, year 32 of personal computing. Jobs moves the Mac to the Intel chip so that Windows can also run on the Macintosh. A brilliant ploy. So now you can run everything on the Macintosh. You have Windows running Macintosh operating system, OS X, and even Linux, and of course, Berkeley-free Unix. Meanwhile, Microsoft, with Windows Vista, creates a new PUI look that many users do not like, imitating Macintosh appearances, but without the integration or clarity that is Jobs' personal hallmark in these operating systems. Sorry, no time for the iPod, iPhone, etc. So that's a summary of the integrated operations, the integrated interplay between Microsoft and Apple over the years. To wind up, both companies were started on a handshake deal between two friends. One fiercely controlling and good at publicity, the other satisfied to stay in the background. Few partnerships have relationships so complementary and stable. Both companies were founded with no investors, allowing the founders to pursue visions no investor would have understood, believed, or allowed to continue. Both companies have fierce loyalty among their galley slaves, customers. Both companies play fast and loose with alliances and with standards. Both companies have cleverly worked out their own monopoly positions. Bill and Steve knew each other from the start. Both men were strong-willed, clear-minded, incredibly competitive, and screamers. Neither invented anything that I know of, but though their names are in patents. Bill Gates is very conventional, a tennis and country club kind of guy who wanted to be very rich just to buy the country club, but not explore new worlds or even leave Seattle. Bill delegates, and as far as I know, left the polishing of each part to the guy who ran it. Bill extrapolated technicalities. His vision was seeing how each new product would fit into the world as it is and communicating that vision to other conventional people like himself. Steve Jobs was a horrible person, a terrible human being, treated people like total shit, and a great artist. Jobs was really basically an auteur, a movie director. Like a director, he thought he delegated provisionally, but he could overrule anything. He had the taste and the clout to tell people to redesign, rearrange, recombine, like a movie director, and the aesthetic sense to keep changing things till they looked just right to him. Steve easily saw what others could not. Others did not see the marketing potential of PUI. Others did not see the marketing potential of Pixar, which by and by took over Disney. Steve was able to see beyond a world that did not exist, and plan the user experience in this world which did not yet exist. just as a movie director plans the user's experience in the theater. Cynical reporters accepting the minority Microsoft view would call Jobs' outlook the Steve Jobs reality distortion field. But in the grips of this reality distortion, Jobs took a bankrupt company, ready for dissolution, to the largest corporation in the world in just 15 years. Whose reality was distorted anyway? Nobody else in the computer field has had both the taste and the political clout to enforce that taste in software designs and hardware designs. But of course, Apple sells software in the guise of hardware, as we all know. Nobody has the power to enforce their taste in the computer field unless they do the programming themselves. Will any large computer corporation ever again find another person with that level of taste and give that person the control to create such a vision? Not bloody likely. Thank you. Hi, I'm Ted Nelson with another tranche of Computers for Cynics. Today's revelation is Hyperhistory. In this one, I figure personally. Sorry about that. Many people think the World Wide Web was my idea. I want to clear that up. The web is a dumbed-down of my idea, but I believe I created the web accidentally by two mistakes I made. We'll be getting to that. Where to begin a history? Depends on what you want to emphasize. I'd begin the story of hypertext with the Rosetta Stone, about 196 BC, the Talmud after 70 AD, the Hexapla of Origin, 3rd century. These are all parallel documents, side by side, connected. The kind of document not possible yet in today's electronic formats, nearly 2,000 years later. Jump to around year 1450, Gutenberg reinvents movable type and prints Bibles, great impact on religion. Shortly thereafter, an enterprising Venetian named Aldus Manutius invents the personal book, which moves the Renaissance from palaces to middle-class homes. Jump 500 years to 1945. Van Nevar Bush, his name is pronounced Van Nevar Bush, President Roosevelt's science advisor, writes an article predicting a machine he calls the Memex, storing all the world's writings on microfilm on the desk. He misunderestimated, a word from another Bush. He misunderestimated how many writings there would be, as did everyone. Van Nevar Bush proposed that scholars would make trails through the world's knowledge, a new form of publication, each author connecting things and adding content of his own. Technical aside, Bush's article also proposed transclusion. 1951, West Coast, Doug's Epiphany. Douglas Engelbart is one of the greatest men of all time, a warm-hearted, soft-spoken, and saintly guy who invented much of our modern world. Doug's name, Engelbart, means angel's beard. Didn't know angels had beards, did you? Well, Doug read Bush's article in 1945 when he was stationed overseas. Then when he got his PhD in California in 1951, Doug Engelbart had a great vision. That interactive computer displays would make possible a new form of collaboration vital for the urgent, complex problems of humanity. And it would be rather like the Memex. It was all about connections between documents, but also connections between people and the dynamics of collaboration. Step by step, Doug went through the painful departmental politics and funding to build a team that would change the world. That was his intention, and that is what he did, though nowhere near what he hoped to do. Cut to the East Coast. In 1960, I, Ted Nelson, took a computer course, and it hit me. The interactive computer screen will be the new home of humanity, the next great media revolution, and I want to be in on it. A lot of people can't understand how I could figure this out without being an engineer, but that's the reason I could figure it out. The engineers didn't have a clue. It took a media person. I'd been an actor on stage and TV. I'd published a little magazine. I'd produced an LP. I'd shot a half-hour movie. I'd seen TV developing from the inside, watching what went on in my father's control rooms at NBC and CBS, starting when I was 10. So the technicalities and art of interaction would be the next frontier. I didn't actually see an interactive screen for 5 years, but I didn't need to. I was a movie maker. I could feel the interactive computer screen. In my mind and heart, I saw it and touched it. I conjured it and caressed it, and it responded wonderfully. Many people still don't recognize interactive software as an art form. Many techies treat the interactive screen as a kind of blackboard, but artists know it as a lover. Here was my new credo. And there would be millions of readers and writers all over the world with their own computers and screens, and they would be able to publish to each other without publishing companies in the middle. This meant new forms of writing. It meant a whole new form of literature. It would replace paper. 5 years later, when I started publishing on the subject, I called it hypertext. I had not yet heard of Engelbart. Okay, technical part. Here was my initial technical design. Whatever the user typed in would be immediately saved for safety on tape, I thought at the time. Each new version would consist of pointers to what was already there on the tape and what you were adding as you continued to write. The method would be safe and efficient and have other benefits which I gradually figured out. How to do the links was a separate problem. That would take 19 long years to figure out, but I feared that if I didn't design the documents of the future, the techies would screw it up, which I believe is exactly what has happened. What I really wanted was to make movies, but I thought it was more important to be the new Gutenberg. Little did I know that Gutenberg went bankrupt. 1964-ish. Meanwhile, in California, step by step, Doug Engelbart builds his lab. He gets sponsorship from Bob Taylor at the Defense Department and assembles a team at Stanford Research Institute, not Stanford U. In this project, Doug proceeds to invent multiple windows on a screen, screen sharing between collaborators, text editing on screens, the first word processing, links between texts, and much more. Technical point. Doug's links weren't embedded. The whole of Doug's vision was greater than these parts. The augmentation of human intellect, especially through collaborative networks of people, constantly improving their networks, their methods of collaboration. Those innumerable parts that I just enumerated of Doug's system were just the hockey sticks for a much greater game of collaboration he hoped to create. Okay, 1965, East Coast. After 4 years of study and design, I submit papers to 4 conferences and every one is accepted. The biggie is the ACM National Conference in, of all places, Pittsburgh. I think that most of the computer scientists in the world were in that room. It was possible in those days. And most of them heard my paper. It was very well received. And I could see that all my work was justified. The only question confronting me was how to get leverage, convincing somebody that I was right so I could get machines and a team together. But how could I make people believe I knew what I knew, let alone what I could do about it? Then somebody came along that appeared to believe me and had the bucks to make it all happen. A few days after my Pittsburgh talk, I got a call from a guy identifying himself as Director of Information Processing Research for the Central Intelligence Agency. He came to my house and asked how I'd like to be funded. People ask me, why would I take money from the CIA? Hey, our country needs good intelligence, and I needed the money to do good things. So I began writing proposals for the CIA, which went on for 5 years till I gradually realized they were just stringing me along, as most prospective backers do. 1966. Meanwhile, in California, Douglas Engelbart invents what everybody credits him for. The mouse. Oops, just dropped mine. In the excitement of trying to escape. Doug Engelbart invents the mouse, which is a big improvement over the light pen. But somehow the process of myth-making has dropped the more important stuff from his reputation one-liner, leaving only inventor of the mouse. Doug's overall vision was and is so much more than that. East Coast, 1967, the HES project, H-E-S. I'm asked to join a project at Brown University that will be a chance to, quote, try out my hypertext ideas, unquote, at no salary. It ends up costing me all my savings. On the first day, I did not get along with the nasty guy who ran the project, but I am not a quitter. I should have quit. As I wrote in New Scientist magazine in 2006, I believe that humanity went down the wrong road with that project, dumbing down interactive documents to one-way jumps among paper simulations, a great and fundamental loss to civilization. The project was called HES, Hypertext Editing System, and it turned out the guy didn't really want hypertext. What he wanted was a system to prepare paper documents for printing, what we now call word processing. I consider this unworthy and entirely the wrong path. You have to choose which it'll be. Are you going to have real electronic documents, or are they going to simulate paper? That project chose appearance of a connection, dumbed down hypertext to one-way jumps and among paper simulations, and this would later become, alas, the structure of the World Wide Web. 1968, West Coast, by which time there were still no personal computers. Doug Engelbart's great demo at the Fall Joint Computer Conference, where he shows cooperative work by people at separate screens, the mouse, hypertext links, collaboration over the phone while people are pointing at the same text on different screens, and much more. At this point, computer screens were still considered exotic and crazy by most of the computer world. Alas, this was Doug's high point, because politics and disagreement took over and his lab gradually fell apart. Big skip to 1974. Again on the West Coast, Xerox Palo Alto Research Center, Xerox PARC, starts hiring people away from Doug Engelbart, and his lab collapses. I was at dinner with Doug a couple of years ago when he actually wept at the memory of how his people had deserted him and how Bob Taylor, his earlier supporter, betrayed him and the vision he had carried forward so faithfully. Alas, Doug Engelbart's system never got to the public. A company called Timeshare tried to productize it, but with no real interest in Doug's greater teaching. What if they put NLS out to a broad public? What if they productized Doug's software for distribution? We'll never know. Now the page turns. 1975, personal computing begins with kit computers, soon also modem kits. 1977, fully assembled personal computers at last, notably the Apple II. Now that some people have personal computers and slow over-the-phone modems, soon there are file-sharing methods, bulletin boards, message boards, forums, discussions, postings. The yearning for online publishing by individuals is at last fully revealed, though most people and big American companies still don't get it, and it's still a small subculture. East Coast, 1979, the big year for my Xanadu project. 6 of us come together, Roger, Mark, Stewart, Roland, Eric, and me, to design our worldwide hypertext network. Note that as of that moment, 1979, there are still very few personal computers in the world, and the only interactive screens most people have seen are airline ticket counters. But we knew what was coming. My team figures out how to do the links brilliantly, making links and reuse work together. This is described in my book, Literary Machines. What it would do: deep hypertext, that is, connected systems of documents with any connectivity and complexity, every quotation connected to its origin by my method from 1960, detailed side-by-side intercomparison between any 2 documents of versions showing which parts are the same and other connections as well. Links in profusion, not embedded but overlaid, a system of publication involving unrestricted reuse of content, but sale of the content could be required by the publisher separate from the document container. Our plan is to put stabilized content on servers with every character retaining its permanent address, stabilized XANU links on servers individually published, nothing at all like web links. Finally, Roger, Mark, and Stewart work out a brilliant unifying addressing scheme with a new kind of mathematics for compactly referring to content and structures throughout this universe and creating new documents and versions as permutations in this space. The boys start programming and Roger looks for backers. He and I agree that he can do the technical development, I'll plan the publishing business, but we're all agreed on certain ideals that would later become popular. Freedom of publication for everyone everywhere. Dodging government controls over free publication. Privacy for everyone that wants it. We see this as a new sweeping mechanism for democracy, citizen awareness, truth-telling, honoring minority views, and the documentation of the world. 8 more long years to the West Coast, 1988. Autodesk backs Xanadu in 1988. 9 years after, 8 or 9 years after what I just told you, my colleague Roger Gregory gets backing for his development company from Autodesk Inc. and its visionary founder, John Walker. Roger and I had agreed that he would develop the Xanadu system and I would work on interfaces and plan the publishing network. Unfortunately, that puts us in different departments at Autodesk, a recipe for danger. In business, your enemy or your suspected saboteur is often the other department. You may know the story of the appointment in Samara, where a man brings on his doom by trying to avoid it. That happened to me. I got a call from one of the Xanadu programs saying Roger was out of control and throwing things, and they were going to quit. So while I had no official status in Roger's development company, I called John Walker, the head of Autodesk, and told him the situation, and Roger was relieved of command. Turned out that Roger was right. He was throwing things because the team wanted to redesign, which would obviously delay the project 6 months or more. With Roger no longer in charge, it was much worse than that. The programmers redesigned for 4 years till Autodesk shut the project down, at which time a very different animal slouched into our ecological niche. So what were the two mistakes I made that brought about the World Wide Web? Mistake 1, participating in and endorsing the 1967 Hess project at Brown that popularized hypertext links as one-way jumps between simulations of paper. I thought it would be fixed later. Famous last words. Mistake 2, urging John Walker in 1988 to demote Roger Gregory from his own Xanadu development company, unwittingly giving up Xanadu's pole position as the world's hypertext system. What if Roger had not been demoted? I believe he would have kept his promise to John Walker and delivered the server network and a workable client within the 1 year he promised, definitely 2. Way ahead of HTML and the Mosaic browser that made it possible. Unseating Roger lost us the world, and no one knows what the world lost. I believe that without these 2 mistakes, humanity would have a far better text system. This is a very heavy burden, but I fight on. To be continued. Thank you. Hi, I'm Ted Nelson with another disclosure of Computers for Cynics. Today's undertaking is the real story of the World Wide Web. In the preceding discussion of Project Xanadu, I skipped over the one-way hypertext systems, one-way jumps between paper simulations based on Hess and Brown, 1967. But in the 1980s, there were lots of one-way hypertext systems. Off the top of my head, on the West Coast, HyperCard, SuperCard, NoteCards. On the East Coast, CALS from the DoD, the Department of Defense, FRES, Intermedia, the Eastgate School of Hypertext, a new literary style, based on one-way jumps with surprises, making literary hay out of the invisibility of the next item till after you select it. Again, that's the Hess design. Oh yeah, and in Scotland, Guide. In 1984, the year of the Macintosh, the CIA finally got their hypertext system, 19 years after they started teasing me with possible backing. It was called Notecards. I have this from Kathy Marshall, who says she worked on the contract at Xerox PARC, and she says it's not secret, just not well known. Would my system for the CIA have been better years and years earlier? Of course, I think so, but who knows? 1986-7, Neil Larson publishes Houdini, a hypertext system with lots of links to documents out on the net. His hypertext products also include HyperRes, PC Hypertext, and TransText. 1988, as mentioned in the previous talk, the Xanadu group stumbled and, alas, got out of control with the unseating of Roger Gregory. Now to 1989, Europe, the first public initiative for what will become the World Wide Web. Tim Berners-Lee, a physicist at CERN, the huge European Nuclear Research Lab, circulates a document entitled Information Management, a proposal, saying, quote, "There are few products which take Ted Nelson's idea of a wide docuverse literally," unquote. Actually, as already mentioned, there were several such products, though the people who made them didn't want to admit it. But in that proposal, Tim also said, there seems to be a general consensus about the abstract data model which a hypertext system should use. Hey, wrong on that one. He didn't ask the Xanadu guys. Our abstract model was off the charts different, but what do you care? Next year, 1990, Tim and Robert Caillot write an official proposal, World Wide Web proposal for a hypertext with a capital T in the middle, and they get support from CERN. Next year, 1991, the web starts up locally. Tim's text format and server software are working and deployed at CERN. It's a preliminary package of text pages, jump format, page structure, directory structure, but it does not reach any general public. 2 years later, 1993, Mosaic. The web browser as we know it makes history. 1993 is when the World Wide Web really happened. The World Wide Web as we know it wasn't created by Tim Berners-Lee, but by 2 university students who pooified the net. That is, they put the PARC user interface, or PUI, around Tim Berners-Lee's document format, repackaging Tim's page layout in an application frame with PARC user interface, or PUI, around it. This created not just jumpable pages, as in Tim's design, but a new hybrid, a puppet theater and shop window, now called the web browser, and Mosaic was its name. The Mosaic vision, that is Andreessen's vision, was to create a user platform essentially competing with Windows and the Macintosh, in which not only could text appear, but interactive applications could be presented, new application cattle pens not boxed inside your computer, but managed from servers on the net far away. Andreessen and Vina could easily have chosen to frame, glamorize, and PUIfy some other format. Certainly if they'd built the PUI to bless Neil Larson's 1986 Houdini format, the Houdini browser, it would have been called the Houdini browser, that would have had the impact of the web. Arguably, it was sheer chance that Tim's format best suited their purpose. Without Mosaic, Tim's format probably wouldn't have gotten any further than Larson's. That's why I think the real creators of the World Wide Web were Andreessen and Vina. Now, who exactly should get credit for Mosaic? Larry Smarr, who was their boss at the National Center for Supercomputer Applications, tells me I'm supposed to say the NCSA browser, National Center for Supercomputer Applications browser, and credit Bina and Andreessen equally. However, it's important to point out that Bina was being paid. Andreessen was doing it on sheer guts and sleeplessness, and many say he should get the main credit. Probably Larry Smarr, too, had something to do with the initiative. So why not call it the NCSA Smarr Bina Andreessen browser, or just PUI on the net? 1994, the impact of Mosaic. One browser to rule them all, one browser to bind them in the land of Mordor where the shadows lie. Thousands, powered by the Mosaic, the web's expansion was now following exactly the expansion rate I had predicted for Xanadu. Thousands, soon hundreds of thousands of users were using Mosaic, and thousands of servers were firing up in companies and apartments, even in secret hiding places. Meanwhile, on the West Coast, Microsoft jumps in with a version of the web browser PUI called Internet Explorer, which gets off the ground fast because Bill licenses Mosaic from Larry Smarr, technically spyglass from NCSA. And also on the West Coast, Mark Andreessen, who has just graduated from college, is taken on as a partner by Jim Clark, just dethroned from presidency of Silicon Graphics. Clark takes young Andreessen on as co-founder of Netscape Communications, Inc. For a kid just out of college to be brought in as equals in a new enterprise by a multimillionaire shows that Andreessen was a pretty impressive character. In 1995, Netscape goes public and brings in lots of money. However, Microsoft gives away Internet Explorer, and that kills the Netscape business hope. By 1999, Netscape manages to get acquired by AOL just in time, and Andreessen and Clark managed to get away with their money by the skin of their teeth. So those were the important events of web history as far as I'm concerned. Younger people would have a different list. As a free-form standard, the web caught on wildly, and the public thinks it's technology, rather than an accidental packaging of a lot of stuff by a bunch of ambitious guys. So whose idea was it? Who, quote, invented the web, unquote? I'm not in this race. I'm neutral on this issue. My team was doing something entirely different, but I want to see people like Neil Larson get the credit they deserve. The notion that Tim Berners-Lee, quote, invented the web shows the process of myth-making. It's like the invention of the telephone. To say it was Alexander Graham Bell who invented the telephone way dumbs down the truth. Many inventors of the telephone don't make it into the standard history. Tim Berners-Lee won the credit lottery for things a lot of guys were already doing, creating viewers and document formats for jump access among paper-like documents on the net. But Tim's document format was blessed, nay, consecrated and sanctified by Eric Bina and Mark Andreessen when they PUIfied it by putting Tim's text format into a frame on the internet, the PUI frame now called the web browser. Bina and Andreessen could as well as bless some other internet text program at that time, like Houdini or Silversmith, or whatever, even Microsoft Word as a world hypertext format by putting it in a network PUI and making it the Houdini browser or the Silversmith browser or whatever. Did Tim have some transcendent, supernatural understanding nobody else did? He would never make that claim. To repeat what he said in 1989, he built on what he considered, quote, a general consensus about the abstract data model which a hypertext system should use, unquote. He put together a clean and professional package around what he saw as a consensual objective, nothing supernatural about that. But he has undergone a deification process that makes people want to believe in his transcendent supernatural understanding. I'm sure Credit has never claimed credit unduly. He's an extremely decent fellow. This is just how the myth-making process works. Where did the parts of Tim's format come from? Embedded formatting was from Xerox PARC, among other places, as it moved into Microsoft Word. Jump addresses and angle brackets were from Neil Larson's MaxThink in 1984. SGML, which Tim renamed HTML, was from Yuri Rubinsky and it had first been used in a browser by Bottoms in 1987. What Tim should get the most credit for is the URL, whereby he harmonized and standardized network addressing, a rational organization across the diverse and divergent file structures of Unix, Windows, and the Macintosh, and indeed the whole world. A hell of an achievement. When people ask me what I think of Tim Berners-Lee, what can I say? First of all, I like him very much. I would compare Tim Berners-Lee to Ronald Reagan. Perfect figurehead. A very nice guy. Very idealistic, upright, totally focused, totally enclosed. I've argued with him for hours at his home in Massachusetts, in bars in Tokyo, one bar anyway. with no sense of communication. But as with Reagan, that could just be a pose, a political stance. He needs to throttle initiatives as much as possible. He is trying to defend the formats of the browser. Tim has a very tough political job. Head of a juggernaut, the World Wide Web Consortium, a political tiger by the tail, with running a system that's getting worse and worse, messier and messier, with lots of politics. People wanted to add more and more junk to the web, i.e. to the web browser. And he wants to prevent that junk as much as possible, or at least organize it in the most rational way he can. Despite Tim's best efforts, the web internals get worse and worse, full of special effects and special cases. The web browser format is still misleadingly called HTML. So when people say HTML, they may think they're referring in some sense to Tim's original clean design, but more and more has been crammed into the ever gnarlier, enlarged definition of HTML, a tangled, mangled, reprehensible mess. HTML is now piled high with hierarchies, the document object model, cascading style sheets from Hawk and Lee, Yarg XML, for which we can thank Tim Bray, tabs, and probably more hierarchies I don't know about. Why? Are documents hierarchical? Sometimes. But let me paraphrase Einstein, who may or may not have said, everything should be as simple as possible, but no simpler. I propose this paraphrase. Every document should be as hierarchical as necessary, but no more so. We must not impose false templates in the pretense of orderliness. Great writing and reporting, as in the New Yorker and other key magazines, is not hierarchical, as it strives to represent all the connections of the story. For web formats to impose false hierarchical templates is highly questionable, if not a cultural atrocity. I have to say something about JavaScript. Okay. JavaScript is the atrocious language of the web browser. It got its name for strange political reasons. It has nothing to do with Java. I'll just say one thing about JavaScript. I was afraid that telling this would be violating my non-disclosure agreement with Google, but I cleared this with Peter Norvig. In men's rooms at the Googleplex, Google headquarters, they post the day's special JavaScript advice over each urinal, thus reaching the programmer through sensory motor channels that conventional documentation cannot pursue. Don't expect HTML to get any better. Just an ever-growing salad of special case effects. They will add garbage to HTML forever, especially when Tim retires, and don't expect it ever to be as smooth as Flash because the JavaScript will always have to pause and garbage collect. Some negative thoughts about the web from the user's point of view. To begin with, the web is about appearance rather than structure. Any structure you wish to represent must be matched into the one-way jumps established in 1967. The very concept of a website is grotesque and should have nothing to do with documents. What I think of as today's typical web page is a flapping, screaming, unprincipled mess with text lines a mile wide that you can't get on the screen all at once because they're locked against rearrangement and they're in pale, tiny sans serif type you can't read anyway. The WYSIWYG model of paper simulation imputes false value to the parts of the rectangle, desperately valued real estate that must be allocated carefully. Articles are broken into individual paragraphs, embedded one by one in bedsheet-sized pages. These isolated individual paragraphs, surrounded by flapping, screaming, jumping animations, are divided into smaller, smaller thoughts, perhaps for the smaller and smaller minds of the Twitter generation. But hey, maybe it's a generation thing. And of course, we have the social web with its new cattle pens. I won't talk about it. And finally, of course, we have the two new super monopolies, both based on cunning uses of the PUI. The Facebook tsunami versus the Google octopus. Hey, the word Google was originally a number, so we can call it the Googlepus. Do you welcome its embrace? Thank you. First, a brief look at something you can come back to. Hi, I'm Ted Nelson, bringing closure to Computers for Cynics. Today's final encounter, pay attention to the man behind the curtain. Everyone takes the structure of the computer world as God-given. In a field reputedly so innovative and new, the computer world is really a dumbed-down and imitation of the past. Based on ancient traditions and modern oversimplifications, that people mistake for the computer itself. In these talks, I have tried, honestly though hastily, to reveal the computer world as a fighting jungle of conflicting agendas, and the debris they have left, a debris created by many individuals, a few of whom I've named. Most of these people are pretty decent guys, but fixated on replicating the past, Aristotelian hierarchies, paper and font, hyper-documents with one-way jumps at most. From the start, they dumbed down the structure of the world to hierarchical directories, highly inappropriate for much of human life, but that wasn't an issue that they noticed at the time. At Xerox PARC, they dumbed the computer down to standard secretarial functions, losing the structure and connection that Doug Engelbart had created, locking users in application prisons and taking away the right to program. At Xerox PARC, they also laid on us crude sequential documents intended for paper printout with abominable editing mechanisms miscalled cut and paste. Those document structures and working methods, the same in almost every system and word processor, were created by, among others, Chuck Simoni, Larry Tesler, John Warnock. They meant well. Now, Chuck Simoni and Bill Gates have gotten so much money and praise for Microsoft Word, and John Warnock has gotten so much money and praise for PDF, that it would never occur to them to deviate from their paper model. Same for the web enthusiasts, too tied up with their grand graphics and cutesy effects to see the sterility of one-way jumps. Just as Xerox PARC trivialized and dumbed down the computer and electronic documents, the World Wide Web trivialized and dumbed down the potential connections of electronic literature. Tim Berners-Lee created the page format, a variant of the PARC document format, adding one-way jumps. Tim also created the addressing scheme, URL, port assignment, etc. But it was put into frame, a PUI, by Mark Andreessen, resulting in the web browser, which built a puppet theater around Tim's simple HTML. And the interior of that web browser has in turn gotten overloaded with special effects and complications, stressing appearances and special case effects, but still having only the one-way jumps from the 1967 dumbed down of hypertext at Brown University. In repudiating this, I stand with my two greatest computer heroes. Douglas Engelbart, my greatest hero, the father of word processing, repudiates word processing because it diverges from the great vision he maintains. It threw away structure and collaboration. Richard Stallman, another great hero of mine, the father of Linux and open source, repudiates open source because it diverges from the vision he maintains. Correspondingly, I, whom some call the father of computer hypertext, disown my bastard child, the World Wide Web, because it diverges from the hypertext vision I maintain. Deep documents with principled reuse, side-by-side intercomparison, and much more that flows from our very different model of electronic literature. I made two mistakes that brought about the World Wide Web, working on that godforsaken HES system at Brown University, which dumbed down hypertext, and acting hastily to relieve Roger Gregory of command in 1988. This is a heavy burden, but I have to keep going. Now, people don't like it when you believe something different. This is called paradigm clash or sectarianism, or among other things. Some people didn't like to hear Xanadu guys talking about some other kind of hypertext or about our alternative to one-way web. And some people knew how close Xanadu had come to being the world's hypertext system, and they wanted to wipe out that memory. So we were attacked by the straight world of web faddists, by that digital fashion magazine, Wired. In 1995, the foulest journalist of our time was hired by Wired, apparently with instructions to finish us off. He wrote what was supposedly a history of the Xanadu project without describing in any way what we were building. Did he mention flying text, parallel pages, visible connection, detailed side-by-side intercomparison, unbreakable links? Did he mention its special features for collaboration, workflow, content management, version management, branching versions, remix and mashup, fine-grained tagging, and what are now called wikis? He did not. None of the above. His 20,000 words, supposedly about the Xanadu project, consisted almost entirely of personal slurs and insults. But most of all, he took pains to imply repeatedly that our work grew out of ignorance. Ignorance! Combining what I consider the greatest possible insult with what I consider the greatest possible lie. But it was what people wanted to hear. It told the computer scientists and the internet faddists alike that they could ignore our eccentric challenge to the conventional world of documents and literature and publishing, that they could ignore our radical technicalities. This foul attack by a foul individual left us without resources or respect, so the project entered a nuclear winter from which we are only now emerging. Like Stubblefield, who invented broadcasting, I know what it is to be eaten by rats. I ask rhetorically, is there anything lower than a dishonest journalist? But Roger and I have pressed on, each in a separate prototype hell. We've gone on independently, somehow staying friends, he working on the advanced server, I working on graphics and interfaces, and I having to dumb it down to more rustic internals based on conventional file structures. People have not understood and have not wanted to understand. All those years I wrote and lectured about the Xanadu project, people apparently only heard the first few sentences and misunderstood in so many different ways. A lot of people misunderstood, thinking we had to have mainframes for worldwide hypertext. I said it could be done on a network of little-ish computers, which of course the web proved. A lot of people misunderstood. They thought we were claiming we would have Earth satellites. Calvin Moores and Claude Kagan misunderstood. They thought I was talking about the track language, which they were working on. Tom DeFonte misunderstood. He thought it was his GRASS graphical interpreter. Dave Weiner misunderstood. He showed me his outliner and said, this is the first Xanadu system. I was furious. It was hierarchical. Tim Berners-Lee misunderstood. What Tim says about me in his book, Weaving the Web, is very friendly, but almost every word about my work is technically incorrect. Bill Gates misunderstood. This is pretty funny. I think it was told to me by Linda Stone when she was vice president of Microsoft. When Bill Gates saw Mosaic, the web browser, the first web browser in 1993, he said to his team, quote, it seems Ted Nelson was right about everything, unquote. I wish I had that in writing. But it shows how completely he misunderstood, since Mosaic, the web browser, was diametrically the opposite of what we were doing. If Tim and Bill couldn't understand our concept, and they're very smart guys, Tim has a first in physics from Oxford, for God's sake, it's not because the idea is complicated, but because our design reverses several paradigms. Here's the concept again. Warning, brief technicalities. In Xanadu structure, content is permanized. The text itself is permanently published and given unchanging addresses. Every character of every new sentence you type gets a permanent address, private or public, your choice. Same applies to audio and video and their frames. A Xanadoc is an arrangement of stabilized content that keeps its original identity and addresses. You change the Xanadoc by a rearrangement and new content, but the content addresses never change even as the pieces move around. Thus, the original context of every quote is always available by following that address back to its origin. Xanalinks, no relation to web links, are not embedded but applied to the content level. This is often called standoff markup. But we apply it to the stabilized content, thus links never break. So a Xanadoc is maintained as a list of content and a list of overlays. We have another form of connection besides Xanalinks, transclusions, the same content knowably and visibly in two places, recognized as the same by its stabilized addressing. That's how we connect a quotation to its source. I've written a lot about the benefits of the system, but Tim and Bill and most of the world never read any of it, so it has to be explained over and over. Ding! End of technicalities. For me, this is not technology. It is literature. It is the future of human work and the human heritage. It's a matter of life and death. I believe the future of civilization depends on getting decent, serious electronic documents, unlike PDFs and e-books. Now, after I say goodbye, look at the beginning of this video again. That's our latest pretty prototype, Xanadu Space. Every quotation connected to its original context, deep connections between parts of different pages, explorable in detail. Don't be fooled by the rectangularity. That's only one mode of presentation. Conventional electronic documents, Word, PDF, and the web, have only one way of showing, and they don't want you to understand the structure. That's called WYSIWYG. But we want you to understand the structure, and we want to offer you many ways of seeing it. That's called WYSIWYNK. What you see is what you never could before. In the firmament of formats, we expect that ours will eventually be the one for the smartest people. Not only do I still want to give mankind a decent document system, but personally I hope I live long enough to write and publish the true electronic documents I've planned for so long, for which no presentational software or editing mechanism yet exists. And obvious, still obvious, alas, to only a few. In closing, I want to thank my tireless collaborator Andrew Pam, and especially my sweet partner Marlene Malikote for their brave, unending support. I want to thank the Internet Archive for companionship, resources, and a place to shoot. And I want to thank you for listening, now, in the past, and in the future. And speaking of the future, you better check the time. It's just starting now.